Do you like to learn, understand, and enjoy and apply the beauty of higher engineering and scientific mathematics? How are you, everybody who is watching this fantastic video? I would like to welcome all the national and international viewers who are watching this program right now in order to enjoy the beauty of higher engineering and scientific mathematics. My name is Olenjolai Moko TAYAI Losingo. Simply just call me Olenjolai. I'm a Tanzanian and I come from Tanzania, and I'm doing these programs specifically by using the curriculums and the syllabus of United Republic of Tanzania, and I'd like to dedicate this program for all undergraduate students who are doing different engineering and scientific programs. So I would like to take this opportunity firstly to welcome our every viewer, national and international viewer, in our online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. Simultaneously, I would like to welcome you into one of our official YouTube channels that called Online Undergraduate Polyinstitute of Tanzania, square bracket OLENJOLAIM. What are we doing in these online institutions? That's the very important questions, and I would like to spend a few minutes just to answer some of the common questions that I know new viewers and even daily viewers, or just frequently, or we call them just consistently viewers, they used to ask themselves that why should I take my time? Why should I use my internet bundle? Why should I use my time? And why should I take online undergraduate Institute of Tanzania, square bracket OLENJOLAIM into the consideration? Well, so we are here, we have a vision, and this vision is come from the founder and the sponsor of these programs, who is our God of Abraham, Isaac, and Jacob. Regardless of your relation, of your religions, we are not focusing on the religion here, we are focused on solving real life problems. So what are we doing in this program? So simply, we have an assignment to train and teach undergraduate students on how they can extract knowledge, wisdom, and understanding from the engineering mathematics fundamental courses, and even also just we call them core courses, and combine it with knowledge, understanding, and wisdom that will teach them to extract it from the Word of God written in the Holy Bible in order to solve real life problems. The main objective of educational system worldwide is to solve real life problems. So we are here in order to challenge you. We are here in order to teach you to think differently, just to be transformed possibly from the present situation that we are seeing that going on. Just that the objective of education is just for you to have a certificate. That's not the main objective. The main objective is in order to teach you to solve real life problems, and that will be the main objective of OPITO. OPITO is abbreviations of an online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAM. So what problems are we solving? According to my research that I did for more than 5 years ago before I began this program, I realized that many undergraduate students who are doing different engineering and scientific programs, they really encounter so many challenges on mastering modules or courses of higher engineering mathematics and higher engineering scientific mathematics. So I have been solving this problem myself physically. I've been teaching in certain institutions called Dar es Salaam Institute of Technology, or DIT, for more than 6 years. So for example, this module or course that I'm going to teach you, probability and statistics, I taught it for more than 5 years. So right now, I thank God by His own grace, this idea, it has been a local training and learning system, but right now it has been transformed into the national level and the international level, because probability and statistics is a cross-cutting course worldwide. So when I say it's cross-cutting course worldwide, it means that every student in the world has to learn. Every student who is pursuing an engineering or scientific courses in undergraduate or bachelor level has to learn probability and statistics as one of the prerequisite modules and fundamental course in every aspect of applied engineering and applied science. So that's the problem that we are going to teach you. So how are we going to solve these problems in your mind? Because I know that you are taking the normal classes, the normal regular classes in engineering mathematics from the GS departments, we call it general study departments, or in some of the colleges or universities, the departments is called departments of engineering for the non-majors. So there are different names of these departments which providing these modules or courses of mathematics, or we call it applied mathematics, which we call the higher engineering mathematics and the higher scientific mathematics. So regardless of which departments it means you are receiving this content, the issue is you have to focus on the course outline or some enabling outcome sheet, which actually that giving you descriptions on what you have to cover as undergraduate students in engineering, in different engineering programs or different science programs about the probability and statistics. So we'll be using different methods, different teaching aids, different teaching techniques and different styles on teaching you in a very simple language, and we take those complex ideas and break them and make them simpler and simpler in such a way that slow, intermediate, and faster learners can take advantage of every concept that you're going to teach them. So I'd like to spend this, then you have so many questions. So thank you, Olenjolai, for brief introductions about the OPITO. So how can you join into these online institutions? Because in any physical institution or college or university, there are some procedures you have to follow, especially in the first week, for you to be a permanent students in that particular institution. So similarly, we have few steps that you can follow them, and you can follow these few steps within a minute, and then you register yourself permanently, and there's no any registration fee. That's the good news that we have for you. So these are a few steps that you have to follow for you to register permanently into the OPITO, which is Online Undergraduate Polytechnic Institute of Tanzania, square bracket Olenjolai. The first step, we ask you to create or open a new email. So please, you can, if you don't have an email, we ask you to create or open a new email. The second step, we ask you to sign in YouTube by using your new email or your old email or your current email. You have to remember your password and your and username. So in case you don't have any email, just go into Google and then write, how can I create a new email? But I know, especially in Tanzania, you cannot apply for undergraduate or bachelor degree programs in engineering or science without having an email. So even myself, my first email, which is Olenjolai moko@rocketmail.com, I have created it when I was applying in different institutions and different courses of undergraduate level. So the third step, we ask you now to search the OPITO. Don't write OPITO. These are abbreviations of Online Undergraduate Polytechnic Institute of Tanzania, square bracket Olenjolai. What we ask you to write in the search engine of the YouTube platform, we ask you to write this name. Just this is online, so copy and paste it, Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAIM. Or even if you write Online Undergrad Poly Institute of Tanzania, then you search, that is fine, you'll find it, and then you'll see a Tanzania national flag, our national flag, like this one. So you see a button which contains the Tanzania national flag, and beside it, it has been written Online Undergraduate Poly Institute of Tanzania in square bracket OLENJOLAIM. You'll see the number of videos that we thank God by His own grace, we have uploaded more than 75 videos right now of this, of the different modules or courses of high engineering and scientific mathematics. You see the number of subscribers. Then the first step, now we ask you that to click the icons with the Tanzania national flag, that's the first step. And then soon you'll see the horizontal tab, which is written home, videos, playlist, channel, then it depends. Sometimes you can see channel, community, and then about. So this horizontal toolbar is very important for you to take advantage of our contents without too much hassle, because we want to reduce your time of searching online on the particular material and the resources that you're looking for. So now the fifth step now, it's the simplest step for you to register yourself permanently and for your advantage. So we ask you, so when you watch at the bottom of your right hand side, you'll see a button which has been written, so it is subscribe, right? So you see written subscribe. So we ask you to click this button, and then once you click it, and then it will change its color, its background color, and the text will change from subscribe into subscribed, and soon you will see the icon of the bell. We ask you to click this icon of the bell once, and then you'll see three options: all, personalized, and none. And then we ask you to click the options of all. So the sixth step, So that is, so after you do that, you have already registered yourself permanently. It's a one lifetime registration. In case that you are you can skip this place if you have, if you have already subscribed, so you can keep on with other steps. Again, these two steps can give you just the few steps or few techniques that you can take into advantage, or you can take them into consideration for you to minimize too much hassling and finding the particular resources. So you can come into, it means that you can come into this top horizontal bar, and then you can find the 30 text or the 30 button, which is written playlist. You can click it, and then, for example, you can search the normal distribution. We used to create our contents. We have departments. We create different departments in playlist. We have departments of higher engineering and scientific mathematics. We have departments of praise. We have departments of worship. We have departments of kingdom of heaven. So all of those departments, you can find them, the particular materials in the playlist. For example, we have also the playlist we have created for normal distribution. We have playlist for the statistical estimation. We have playlist for hypothesis testing, you see. So you have a playlist for the entire, which is called probability and the statistic. But these modules, it's a little bit, it is being taught in a different style in different institutions, colleges and universities of engineering and science in Tanzania. So we took that into consideration, and we just did that. We are teaching this, for example, with the perspective of the NACTE system or NACTE syllabus or curriculum. But statistics and probability, remember, it's a universal module. It's a universal cross-cutting engineering, high engineering and scientific module or course for undergraduate or bachelor students. So right now, let us go into the session for the today, which is lecture 2. We are in departments of what? We are in departments of high engineering and scientific mathematics. And then the course of the module of the day is called probability and statistics. These contents in most institutions is taught in to the second year or first year bachelor engineering students or bachelor science students. In NACTE systems is called NTA level 7P, okay, or NTA level 7, that's enough. And today we are still in chapter 1 that's called normal distribution. This is lecture 2 that's called normal distributions curve and table 4.4. So then I will give you some descriptions later on, just you have to stay connected and stay tuned into this fantastic moment. So, ladies and gentlemen, let us review into a quick, let us get into a quick review of lecture 1. So, in lecture 1, we taught you basically what is normal distribution. And then after we learn about normal distributions, we find that we'll be dealing with random data, okay, or random variables that we call the random variables. And then we jumped into the characteristics of the normal distribution curve. And I taught you 5 characteristics of the normal distribution curve, and these are the commonly questions in most of test 1 questions or most of test 1 setup, right? So the first characteristics, if you do remember that, so basically we define what is normal distribution. So what is normal distribution? So that is the question you have. What is normal distribution? And then the next concept that we'll be focusing on what is characteristics of normal distribution. And the first characteristic, we say that area under the normal curve is always equal 1, right? Or probability, or we say that sometimes you say this is equal to the integral from A to B, and then the derivative function d of x, like this one, this is equal also to what? To 1. And then the second property, we say that the second property, or the second important property of any normal distribution, we say that all normal distributions are symmetric about the year mean and have a bell-shaped. All normal distributions are symmetrical. So you say that all normal distributions, and we'll use this property today, symmetrical, with about a mean. So about a mean. So all the normal distributions, and just let me remind you that the normal distributions that we are talking, it's in bell shapes. All the normal distributions are symmetrical about the year mean, and they have a bell shape. Okay, so this we call it bell shape. So this is bell-shaped normal distributions or bell-shaped curve, right? So bell-shaped curve. So you say that they are symmetric about mean, and this is what you call the mean. However, as a result, this is a standard, and this is probability of of standard value. And then the third characteristics, we say that normal distribution curve extends from what? From negative infinite to positive infinity. And then the other ones, we say that all the normal distributions, the first characteristics, the mean, mode, and median of normal distributions are always close to each other. So you say that the mean, median, so you have to review lecture 1 in case that you missed it, and mode are close to each other for any distributions, close to each other. And then the last property, we say that all normal distributions, the probability density function of normal distributions is given as a certain probability function, which has been introduced by the great mathematicians that call the Gaussians. Right? So you can pause the video and then you copy these 7 steps for you to register permanently. And then afterward, I would like just to take you into the today's session, or into the today's contents, which is lecture 2. So today I'm teaching you the concept that we call the distribution curve. And this is the foundation of all other all other topics for the entire module or course. So we are teaching you about normal distribution, okay, normal distribution curve, and then we are focusing on areas under the normal curve. So this is called it is area under the normal curve. So you can have it. I mentioned that the reference areas under the normal under the curve. Okay, simply these are from what? So area under the normal curve from 0 to Z. Simply this we call it table 424. So you have to take this table, right? So you have to take this table and should have it in your hand. And then this is called the areas under the standard normal curve, areas under the standard. So even this one under the standard. So here we have the word standard. And here we have the word under the standard curve from 0 to Z. So this is a simple representation. I think that you have it. It is table 4.4. It has been labeled. These are available, accessible. You can find them and you can maybe have a copy of it. We are going to use this table for the entire course or for the entire module. So you should have it in every session or in every lecture that you are going to take. You should have this in your hand because it will be one of our important reference. That's why I mentioned it in the first in the lecture, in the general introduction, in the lecture 00, general introductions to probability and statistics. So this is the simply representations or just a brief representation. So if you check this table and you compare with yours, you have how many columns? You have 11 columns. The first column, second column, third column, fourth column, fifth column, sixth column, seventh column. So listen. So this is first column, second column, third column, fourth column, fifth column, sixth, fourth column, seventh column. Okay, then there's the 8th column, so I jumped to here. Then there's a 9th column, there's a 10th column, and there's the 11th column, right? And how many rows do we have? So we have the first row, 1, 2, 3, 4, 5, okay? The rows are being grouped into 5, right? The first row, the first 5 rows have been grouped together, and then there's a small space, right? If you check it, and then there is other 5 rows grouped together, and then there is a small space that's being left, and then there is a 30 group, the 30 collections of 5 rows, and the 4th collections of 5 rows, and the 5th collections of 5 rows, and the 6th collections of 5 rows, and the 7th collections of 5 rows, and the 8 collections of 40 or 5 rows. So we have 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 collections of 40, 5 rows. So 8 times 5 is equal to what? 40. So table 4.4 contains 11 columns and 40 rows. But the first very important point. So this is you have to know. So table 4.4 contains what? 11 columns. 11 columns and what? And the 40 rows. 40 rows. Right? 40 rows. So that's the first key point that you have to understand. Again, on top of it, we have that subtitle or title, that areas under the standard normal curve. Under the standard normal curve. So yeah, under the standard normal curve. Areas under the standard normal curve. Under the standard normal curve. So areas under the standard normal curve. Area under the standard normal, under the standard areas under the standard normal curve from 0 to Z. Very important subtitle. And then here we have the curve. So this is what we call the standard normal curve. Right, from 0 to Z, and then you have a shaded area. And here it is being labeled as what? Table 4.4. Very important. Okay. So then let us let me explain what does this table 4.4, or what does areas under the normal areas under the standard normal curve under standard normal curve from 0 to Z means. What does it mean? So let us go inside of it. So you say the first column, right? The first column represents what? Represents different values of what? Of standardized normal variable or normal variable Z, right? Okay, from what? From 0.0 to what? 3.9 in 1 decimal place. In 1 decimal place. So in 1 decimal place. So mean that here it jumped how many rows? So because we say we have 40 rows, so it jumped it, so these are 5 rows, so it remains that 5 rows minus 3, it means that 7 rows, so I've jumped it, no. Okay, this is 5 rows minus 3, remains 32, so I've jumped it 32 rows. So what you can identify that the first column, this first column, ladies and gentlemen, of undergraduate or bachelor degree, the first row, the first column, which contains 40 rows or 40 values, yes, 40 rows, represent different values of Z or standard normal value Z from 0.0 to 3.9 in 1 decimal place, right? So that's the boundary. So it means table 4.4 will give you the probability within 0 to 3.9 within means that the table 4.4, which is called areas under the standard normal curve from 0 to Z, gives you probability from standard value of Z is equal to 0 to Z is equal to 3.9. But in both area, on both sides of the line of the symmetry of the normal curve. I will explain to you how we use this table and then how we can replicate, because this table gives you the areas under the normal curve from 0 to Z on right hand side, but also it can give you the probabilities or areas under the standard normal curve from 0 to negative z. But I will teach you the technique that we are using. But currently, you have to focus that it will give us what the probability within the range of 0.0 to 3.9. That's a very important point. The second point. The first row, right? This first row, which has values 0 to 9, right? The first row simply representing 0 less than or equal to what? To 30 less than or equal to 9. Simply, right? This is represents what? So the first row represents values of what? Values of second decimal place of what? Of them. So say the first row from 0 to 9. The first row, ladies and gentlemen, I have already the second sentence, and this is number 3. So the second sentence representing the first column. So here we are talking about first column, and here we are talking about the first row from 0 to 9. Okay, represents what? Values of second decimal place of 40 of them. So it means that this table 4.4, which is called the areas under the standard normal curve, gives us probability of the standard value in 2 decimal places. So if we'll find the normal distribution, maybe the standard value Z is in 3 decimal places, so we have to make sure that you approximate in 2 decimal places. So if you find with no any decimal places, we have to make sure that we define it in 2 decimal places, which is maybe that value of 30.00. So it means that in the standard normal curve, the standardized value Z is always in 2 decimal places, right? So it means that for example, when Z, so for example, this probability is mean that Z is equal to what? So you can have now Z is equal to 0.01, maybe 0.02, maybe 0.03, etc., etc., etc. So remember that whenever we are finding the probability of Z, we have to make sure that the standard normal value Z is in 2 decimal places, right? That to say that not before the value of Z should be in 2 decimal places. Example, Z is equal to 0.04, Z is equal to 0.97, Z is equal to 0.4, no, there's no 0.4, yeah, 0.49, then it can be also 0.7, then it can be 3.71, for example, that can be 3.96, etc., etc. So remember that the first column presents values of Z in 1 decimal places. The first row presents the values of Z as of the second decimal place. So remember that any value of the standard normal curve Z should be in 2 decimal places. So bear that in your mind for the rest of your life of probability and statistics for undergraduate or bachelor degree students. So that is fairly sentence, silly fact. The first fact, we say that Now, the second column so say the second column, second column, the second column, second row, so say the second row to the fourth row of first column to 11th column. 11th column represents areas or probability under the normal curve, under the standard normal curve, under the standard normal curve, under the standard normal curve from 0.0 to 3.9 in 4 decimal places. In 4 decimal places. Right? What does it mean? Read carefully this sentence. The second row, ladies and gentlemen, the second row, this one, right? To the fourth row, this is the fourth row, 40th row, okay, 40th row of the first column, this is the first column, to the 11th column, this is the 11th column, represents areas, or we call it probability. Remember, probability is equal to areas, and areas is equal to probability, under the standard normal curve from 0.00 to 3.99 in 4 decimal places. So these are the probabilities. These are the probabilities. These are probabilities. So all of these are probabilities in first column. Probabilities in first column and the 40th row. Probability in the first column and the 40th row. So and 39th row. So the probability in the 39th rows in the first column. Probability in the 38th rows and the first column. So this is the probability in the in the 5th row, in the in the third in the 6th column, right? So these are the probabilities. So you see these probabilities, this is decimal point. So all of these probabilities are 0. For example, this probability read 0.0000, and this probability read as 0.040. This probability read as 0.080. This probability read as 0.160, and this probability read as 0.359. This probability read as 0.1255. This probability read as 0.4999. This probability read as 0.1700. This probability read as 0.1879. So all the probabilities that we'll be reading in from table 4, which is titled as areas under the standard normal curve from 0 to Z, will be in 4 decimal places. Keep this in your mind, right? Keep this in your mind. So even if that will be given in 2 decimal places, we have to add the other 2 decimal places to make it 4, right? So that's the point you have to remember and bear it for the rest of your life when we'll be learning together. These are the concepts of all the 4 topics of all the probability and statistics in this course under the syllabus and curriculum of NACTE, which is being taught or applied by the Dar es Salaam Institute of Technology, or in short we call it DIT, for the second BNG or BSc undergraduate students or bachelor students. So that is the overview. So you see the overview. So this we call the overview of of area under the standard normal curve from 0 to Z, table 4.4. So that's all. So the next step, just we can go to application, right? How we can use this table to get areas under the normal curve. Remember, areas in normal distribution curve, areas under the normal distribution curve is what we call the probability, right? So stay connected. In case you have any questions about the overview of table 4.4, which is titled as areas under the standard normal curve from 0 to Z, please ask it in the comment section. And use the comment sections also to give us feedback, whether you understand. And also give us that how did you find these contents relevant for the rest of your life. So now we are going into then how, so finding, okay, use of what? Use of table 4.4 to find what? To find areas under the standard normal curve. Okay, areas under the standard normal curve. So I'm going to teach you more than 5 cases. So we'll call them this in terms of cases because we'll be checking different shapes of of the curve, or the standard normal curve, right? So we say that we have case 1. So one thing which I want to tell you that here we have 40 rows, but we have also other invisible 40 rows. So in total we have 80 rows. And also you have, here we have 11 columns, but we have also other 11 columns. You're asking yourself, what are you saying, Sir Olenjolai? What are you saying, Engineer Olenjolai? Okay, well, so stay tuned, and then I will answer your questions and your doubt. So these are, ladies and gentlemen, let us start with case 1. And this is case 1. We say that let us focus area under the normal curve from what? From 0 to Z, right? So from 0 to Z. So let us start with this one. It means that use of the body. So so say that finding. So let us start with use of table 4.4 titled as areas under the standard normal curve from 0 to Z. Okay, to find what? To find area from what? Or areas under normal curve under the standard normal curve from 0 to Z. So the first step, we say that consider the curve below. So consider the curve below. So which curve we have to consider? So right now we are doing, in case you have any question, don't hesitate to ask me in the comment section. Remember also I'll leave the homework for you. And remember that today we are learning, if you join with me right now, we are learning what? The overview of what? The overview of, so we say that this is the normal curve. This is the normal curve. And then here we have areas. Areas under the normal curve. So this is the symmetry. So listen carefully. So remember that we say that the horizontal line representing what is the standard normal curve. And then the area of concentration, we say that you want to find area under the normal curve from 0 to any value of them. From 0, let's say, to 3.5. From 0 to 3.8. From 0 to 0.8. So how do we find this probability, right? So this is the first step, and which we call the normal curve. And we have to, how can you use? So simply we say that we go for the second step, if that's the requirement. So we say that we have to mean that use table what? So use table 4.4, right? To read what? To read probability. P stands for probability from 0 less than or equal to Z, or less than or equal to what? So let's say this is Z1, right? So less than or equal to Z1. So this one from 0 to what? To Z1. Okay? So to find the area under the normal curve from 0 to Z1, then we use table 4.4 to read the probability from 0 to Z1. And in this case means that, for example, remember that, so probability from 0 less than to Z less than Z1, simply in the table will be reading probability of 40, probability of Z is equal to Z1. That's what we are going to read. Okay? So we have here example 1, which you have to refer. There is an Institute of Technology final exam of 2018, not final exam, is it final? Yeah, final exam. And also this question has been asked in test 1. Okay, in test 1. And the question is, state 3 characteristics of 40 of normal distribution. If you manage to answer this question, you'll be awarded 3 marks. So that's example 1. So example 2, I should give you this example or that question in lecture 1. But unfortunately, I forgot it. That's why that I gave you in lecture 2. So, example 2. Okay, example 2. So, the question state is, what is area under the area of the curve, area of the standard normal distribution of the standard normal distribution of the normal distribution lies under the normal curve, under the curve over what? Over 0 less than 30 less than 0.42. Or sometimes at the end, yes, this is the way that the questions used to be. So what is area under the standard normal distribution curve? Now, standard normal distribution curve lies under the curve, of the normal distributions lies under the curve over 0 to 0.42. Wonderful. This is a very simple question for undergraduate students, and if you've understood my overview, if you've understood my teaching about the overview of table 4.4, the areas under the standard normal curve from 0 to z. So solution. So the first step for you to solve these problems, you say that sketch the normal distribution curve. Sketch the normal distribution curve. Okay, the normal distribution curve. So this is the way that we sketch. Okay, so we have to include also the bell-shaped curve, and this is what? The symmetry. So this is 0. Okay, so here it's a point. We say this is what? So here it is 0.42. What should we find? The area under this curve from 0 to z is equal to 0.42. Okay, so remember that this is depends. Can call it table 2.1, as you can call it. So you need to find area or probability from 0 to 0.42. Right? So how we solve that problem? So the first step, we have sketched the curve and we saw the boundary. So right now, we have to make sure that, okay, so we go for the second step. The second step, we have to find the probability. So how do we find it? So we say that use table 4.4 to read what? To read probability from 0 less than or equal to z, and this less than or equal to 0.42. And you have to remember that probability 0 less than or equal to 30 less than or equal to 0.42. This is equal to probability as 30 is equal to what? 0.42. Okay. So how do you use this table? So you say that, okay, so simply probability from 0 to 30 and that or within 0 and 0.42, you expect the response to be in 4 decimal places. So first of all, what the decimal point of that is the value of that you have to find in the first column. The first decimal place is 0.4. So 0.4. So it means that 0.4 is the first decimal point. So you have to look in the first column where we find the values of standard normal value. So 0.4, it is 20. Then we have the second decimal place. Well, the second decimal place is 2. So we have to look from the second column to the 11th column. The second decimal place of 2 of date. So this is 0, this is 1, this is 2, right? So remember that the first decimal place of date is 0.4, and the second decimal place is 0.02, so it is 2. So simply, I have to move down in this way up to here, and then I have to move horizontal up to this one. So this is the probability of this is the probability of 0 less than or equal to z less than or equal to 0.42, which is called the area under the normal curve is equal to 0.0. So because of these decimal places, we read as 0.1628. So 0.1628. So that's the response. So therefore, probability, so you can just eliminate this probability from 0 to 8, or from 0, the probability within 0 and 0.42 is equal to 0.1628. That's all. We're done. Wonderful. Simple. Okay, so that's the first case. Case 2. Case 2. Okay, use table 4. Okay, so before case 2, let me give you one of the simple questions. This is example 3. So this is quiz. Yes, we have a quiz, and then so we have also other parts that we have to help you. Because we'll be having quizzes, homework to make you active learning. Use table. So this you have to refer the IT manual. The IT manual. Use table 4.4 to answer the following questions. Following questions. A. What areas under the what area of the standard, what area of the standard normal distribution lies under the curve over 0 less than that, less than 0.45. B. What proportion of standard normal distribution curve. So this is quiz. Try now. Standard distribution lies under the curve. Normal distribution lies under the curve over 0 less than that, less than or equal to 0.45. So what's the probability that the standard normal variable z will take on the same value in the interval? So what is the probability that the standard normal curve normal variable Z will take from the same value from 0 less than or equal to Z less than or equal to what? To 0.45. So that's a very simple question. You can read the descriptions for you to get more details. So what areas under the standard normal distributions lies under the curve over 0 to 0.45? And then start the quiz, and what the proportions of the standard normal distributions lies under the curve over 0 less than or equal to Z less than or equal to 0.45. And then what is the probability that the standard normal, this is the repetition, so normal variable Z will take on the interval, okay, on the interval. So on the interval from Z less than or equal to Z less than or equal to 0.4. So solution. Okay, the first step. The question, the example 3ABC, this is the same question, but just different vocabulary. The vocabulary here is the word proportion, and here is probability, while here it is area. So you have to notice the first step, not before. So not before. The word area, whenever you see area in probability and statistic, area is the same meaning with proportion, and the same meaning with what? With probability. So that's the first step, you have to note it. The second step, if that is case, say that sketch what? Sketch the standard normal curve. Standard normal curve. Find the probability that you're looking for. Okay, so then this is 0, this is 0.45. So you have to find area or proportion or probability under 0 and a 0.45. So this is called theta what? This is curve, right? So it's standard normal curve. Standard normal curve 2.2 to the correction. Okay. So if that the case, we say that the third step, we say that rate probability of 0 less than or equal to Z less than or equal to 0.45 in what? Interval 4.4 half. So probability of 0 less than or equal to Z less than or equal to 0.45, which is equal to area. This we use the table. So the first decimal place of the standard normal variable z is 0.4. So 0.4, this one. Then the second decimal place is what is 5. So you have to check from the second column to the 11th column. So where we find the decimal places of 5. So we check here this one. So the point of intersections is we just go down and then we move right hand side to this point. So this is 0.1736. So that's the probability. So it is 0.1736. So this is the response for Roman A, Roman B, and Roman C. Wonderful. So so now let us go to the case 2. I think that you have finished to copy this question. In case you find that maybe I'm writing quickly, you can pause the video and copy the information, then we have to move on. So case 2. So case 2 is that use of table 4.4 to find what areas under the normal curve. Under the normal curve. And standard normal curve from 0 to negative z1. What if the area under the normal curve is on left hand side of 0? Okay. So to find this one, we say that the first step, we say that it's just a sketch. Okay, the first step. Sketch normal curve. What if we are talking about negative side? Normal curve from what? 0 to what? To negative z1. So the value of the standardized, because we define the value of standardized, the value in both in the positive value and negative value. Okay, so then this is z is equal to 0. Remember that. So what are we talking about? This is where we have negative z1. So how can we find this area under the normal curve while the table 4.4 gives the values under the normal curve on the right hand side of 40 of our standard normal curve, Okay, so how can you find that case? Okay, so ladies and gentlemen, suppose that this is normal curve. So we call it normal curve 2.4. Okay, so simply this is called the probability from negative z1 less than or equal to z, and this is also less than or equal to 0. That's what we have to find. So what technique? Where do we find these probabilities on the negative hand side, on the negative side of 40 of 0? So that's why I told you the table 4.4, which is titled as areas under the normal curve, or areas under the standard normal curve from 0 to z, contain 11 columns and the 40 rows. But I told you also there are other 11 columns and 40 rows which are not shown in table 4.4, but we use them in the context of finding the area and a normal curve. And that invisible 40 rows and 11 columns are what we call them areas and a normal curve on the negative side of Z. Okay. So second step. Second step is that use the concept of what? Of symmetry of what? Of the standard normal curve use the concept of the symmetry of the standard normal curve to find what? To find area from 0 to negative Z1. Z1 can be a value of any standardized normal value, right? Okay. So how do we use it? So by using the concept of the symmetry, we say that the given normal distribution curve has the shape of or represent the probabilities on the right hand side of 0. So this is what it has been represented. The given table gives you the probabilities from 0 to any positive value of date within the range of 0 and 3.9. So, what if you suppose that this is, we say that in finding the areas and the normal curve within 0 and 1, there is no problem. So now, what do we say? We use the concept of the symmetry. Concept of the symmetry, right now, we want to find the area and normal curve within this region. Right? So within this region. In this region. So this is negative Z1. So by using the concept of the symmetry, we say that area under the curve from 0 to 31 is equal to area by the symmetry under the curve. Okay, from what? From negative Z1 to 0. I have to do minor changes here. In this case, we are dealing with from negative 30, negative Z1 to 0. So even this one. So we say that from negative 31 to 0. So from here to here. So by using the concept of the symmetry, we say that if, for instance, Z1 is equal to 0.45, and the ones on the left-hand side, it means the area under the normal curve from 0 to positive 0.45 is equal to the area under the normal curve from negative 0.45 to 0. That's the concept of the symmetry, because symmetry is a line that dividing the normal curve into two equal parts. So remember that. We say that it is the line of the symmetry, the area from 0 to negative to positive infinity is 1, is 0.5. And the area from 0 to negative infinity is 0.5. Why? Because of the line of the symmetry. Similarly, the nearby areas from 0 to Z1 and from 0 to negative Z1 is the same. So this is the concept that you have to remember, that we can use table 4.4 to find areas under the normal curve bounded by the negative values. That's the point that you have to remember, right? By using the same table, but we are using the concept of photovoltaic, it means we'll be reading from this table, but we mean that that probability is on the left-hand side. So that's the point that you have to remember. So remember that. So if that's the case, you say that probability, so from that fact, probability from negative value 1 less than 0, this is equal to a probability of from what? From 0 less than that, less than or equal to positive value 1. That's the concept. Okay, that's the concept. So by this fact, then we can solve different problems. Okay, so if that's the case, you say that, okay, so let us see the example and then we end this session. So example 4. Okay, what is area? What is area under the standard normal curve lies in negative 2, okay, negative what? Negative 3, 20, 7, 8, and 0. Solution. As I told you, the first step, sketch the problem. Sketch the problem means that you sketch the normal curve. You say that you are looking the area under the normal curve within this given range. So this is the symmetry. So this is what? Negative 3, 27, 8. So you are finding area under this curve. Finding area of this shaded region. So this is 0. And as I said that this is curve, normal curve, 2, 20, but 2.5. So you have to find that area, right? So it means that the second step, remember that table 4.4 does not contain values of Z of negative. Does not contain the negative values of Z, whether in one decimal place or in another decimal place. So the second step, we say that use the characteristics of what? Of symmetry of normal curve to find what? To find, okay, of normal curve and what? and the table 4.4 to find probability from negative 3.78 to 0 less than today. No, less than to 0. So how? So mean that by the concept of symmetry is the fact that you are looking the area and the normal curve on the left hand side of 0, but we have the same. So the magnitude, so we say that this is the concept of the symmetry that you are going to use. We are looking the probability from here. This is negative 3.78. Okay? This is our desired end. But by the concept of symmetry, we know that we can find the area under the normal curve from 0 to 3.78 in table 4.4. So this is normal curve. This is normal curve 2.6. Right? So it means that by using the concept of the symmetry, say probability from negative 3.78 less than that, less than 0. This is equal to probability from 0 less than or equal to z less than or equal to 3.78. So if that the case, we say that therefore mean that, okay, so it means that this is the steady state. So we say that use what? Table 4.4 to find it. To find probability from negative 3.78 less than that, less than 0. This will be equal to what? So you're using the same table. The first decimal place is 3.27. So this one. And then the second decimal place is 8. So in order to use our table, let me adjust. Let me do minor changes. Instead of 8, here let us use 9. Okay? Instead of 8, let us use 9 because I want to use the table 4.4 that which we have its probabilities on the table. So this is 7.9 and this is 7.9. Okay, this is 7.9. So for you, it should not change anything. It's fine. Okay, because the issue is to understand 7.9. Okay, to find out 7.9. So the first decimal place is 3.7, this one. Then the 11th columns. So we got the 11th column. So this is the point of intersection. And this is the point of intersection. Even if that you are looking the probability of 40 within negative 3.78 will be the same. Because you see that these probabilities are in the last 3 rows are the same. So this is equal to 0.4999. And that the response. There's no need for you to have negative or to put negative. Probabilities are always positive values. Okay. So it's a time now for the homework. And this is homework 2. Okay. And this is example 5. And we have to refer the team manual. And the question is straightforward. Use table 4.4 to find area of the normal distribution under the curve under the curve. If you have any question, don't hesitate to ask in the comment section. Under the curve, negative 1.67. This is the fundamental point for you to master this content. So if you understand how to use table 4.4, then you can go further as God will take you. So you have to make sure that you watch this video several times, and also you share with your colleagues in order for you to enjoy the beauty of higher engineering and scientific mathematics. So ladies and gentlemen, this is the end of lecture 2 that titled normal distribution curve and table 4.4. So join me in the lecture 3 when I will take you again into case 3, case 4, case 5 and even case 6 of what, because we still have the example that we have area within this, and then in case that we have maybe area on this side. So I think that we still have 3 other cases, and that's going to be solving problems by using table 4.4. I know that possibly this content might be different from the content that you are learning in your regular classes. That should not be the case. You have to be careful, and you have to take this into advantage and combine what you'll be learning in your regular classes in any institutions, college or university. So join me. This is Sir Olenjolai, and also I'm electronics and telecommunication engineer. So I'm teaching you what we apply in engineering. Keep on thinking how you can take these classroom instructions on solving a real life problem. So I love you so much. May God bless you. And remember that you give me feedback in the comment section. Submit this homework in the comment sections about your area and normal curve, because I know that you can write by using just the normal keypad of the mobile phone or iPad or computer or any other electronic devices which can access internet and can also give you